Hey there. All right, so in this video, we're going to be walking through a little bit about item response theory. Now, item response theory, we really use item response theory because we're interested in the relationship between the measurement process, so having a questionnaire and a set of items, and how well we are measuring some trait of interest, some underlying trait. So it could be um, personality, it could be ability, etc. Just an underlying trait like that. We want to know how well the items in our scale um, essentially discriminate between respondents if our respondents have a different level of the trait that we're interested in. So we're looking at things like discrimination and difficulty uh, in an IRT context. Um, so first things first, we got to load our data, for the sake of time, I've already loaded the data set. But per the assignment criteria, our data needs to be 100 plus observations. We need to have 4 plus Likert scaled items that measure one construct. So we're going to have to test for unidimensionality, which we'll talk through in just a second. But essentially, with a Likert scale questionnaire, that means we have our questionnaire is not dichotomous. That is, we don't have two responses. We have more than two responses. So we have a polynomous scale that we're assessing using IRT. And then we're going to run our graded response model parameter estimates. Those are our B and A parameters. And then, of course, our item response category characteristic curves and our item information curves. We'll talk about each of those in turn. But all right, so first our data, making sure that our data meet the requirements. We see that this data set specifically has, looks like what amounts to about 3 scales associated with a particular type of justice. In this example, we're going to be walking through IRT using the procedural justice scale. So we've picked some items from that scale. And because I don't want to use the whole data set, so I don't want to use this whole data set here, I just want the specific items. So I have used a data frame to specify which items I would like to use in running the next bit of code, our next bit of analysis, as we'll see. But anyway, so I basically trimmed this data set. So I call it IRT trimmed. But again, it's just a data set or a data frame specifying which of the specific items that I would like R to use. Okay, so in other words, these are our 4 items that are measuring the latent construct procedural justice. And I used items 3, 4, 5, and 6, which are interestingly out of order, but so anyway, so we have our items. Now we want to test for unidimensionality, and unidimensionality essentially means that we have one underlying construct, one underlying factor that is driving these values. So essentially, again, looking at our assignment, items that are from one construct, aka unidimensionality. And to demonstrate that, I used an exploratory factor analytic approach. And as part of that approach, the first thing I wanted to do is test. I ran a Bartlett test to determine the relationships between my items, my 4 items here. I wanted to see essentially how related these items are. if they're super related, I'm essentially measuring or assessing the same thing, same underlying construct, using the same item. So I want to make sure that these items are different enough, but that they're still measuring the same thing. Essentially, we're checking to make sure that we're not, that we don't have an identity matrix, essentially. So I'm going to go ahead and run that, and ideally we want this test to be significant, because here's our significance value, which is 4.9 or so to the negative 165. So that's pretty significant. But what that tells us is that we're not looking at an identity matrix. So that while there are relationships in this data set, they're not super correlated to where they're measuring the same thing. In other words, the items aren't the same. All right, so now we're going to get into the actual EFA exploratory factor analysis portion of the unit dimensionality check. So I'm going to run this here. Boom. All right. So basically, looking at the code here, I used an FA command, which is essentially saying, I want to run factor analysis. I want to run factor analysis based on the trim data set. And then in factors, I'm specifying the number of factors that I have. So I have the 4 factors, aka the 4 items I'm interested in. Because I'm looking for unit dimensionality, I'm not really interested in how the items rotate. And this basically is saying, where it's specifying which approach I'm using for my EFA, which is a maximum likelihood approach. Okay, so this is our EFA portion, and I'm basically pushing all of this information into the value or variable EFA1, and then I'm calling for that value, so it spits out my information. Let's see, scroll up here. So because if I ran this, all it would do would push in all this information to EFA1, and it would just leave it. So I want to make sure to call that forward, and then I want to plot the eigenvalues. So I want to plot the eigenvalues of my EFA. So I went ahead and run that. Right. What that gives us is a scree plot, or the knee and elbow method. Ideally, we want, again, for unit dimensionality, we want to demonstrate that we have one factor, that the items are loading onto a single factor. So the way to test that is that we have one item, or not item, excuse me, that we have one factor that is above 1, and the rest of them are below 1. So for example, if we had a circle here, and a circle here, and then our scree plot leveled off, that would essentially tell us that we have approximately 3 factors that the items are loading onto. But that's not what we want. We want a single factor, and we see there that that's in fact what we have, as all of the other factors are below 1. So we're going to get rid of them, or not consider them. So all right, great. We have our test of unit dimensionality. Now, I should mention that when it comes to testing unit dimensionality in an IRT context, there are many different approaches that can be used. I decided to use the EFA approach because of the numerous amount of times that I found that it was actually cited and used in the literature, which I'll talk a little bit more about in my results section. But all right, so there we go. We've demonstrated unit dimensionality. We have the data requirements met. Now we get into actually running and conducting the IRT. And we want to make sure that we have the LTM package. And so we go ahead and load that. And then now we're here at line 22, 23. Now we want to run the graded response model using the trim data set again. So I'm going to go ahead and run that and talk a little bit about it. Oh, again, we got to make sure we call for the model after we push the data into our variable model here. So basically what this has done is given us our first test to be run in our assignment, which is the parameter estimates for our item characteristic curves. So this is, again, our B and beta parameters. Then the B parameter is assessing difficulty, and the along our, well, I'll go ahead and run the rest of this so it's a little easier to explain. Here we go. Boop. All right, so now we can go back. Boop, there we go. All right. So again, B is looking at the item difficulty with respect to our theta, or our underlying ability that we're trying to assess. And then we're looking at the relationship between probability of response and where in the theta space that item actually falls. So is it a relatively easy item? Is it a medium item, or is it a hard item? So, easy, medium, and hard is kind of relative, but essentially in this polytomous data set that we're using, where we have a five response or 5-point Likert scale, we're not necessarily looking at the difficulty of the item as much as we're looking at the probability of response to that item. So probability of response to one of our choices given the degree to which the respondent possesses a particular level of our underlying construct. So in this case, we're looking at procedural justice. So ideally, we have a 5-point scale, which would presumably be from strongly agree, disagree, neither agree nor disagree, agree, and strongly agree. So in other words, so if one is, by that logic, one is strongly agree, someone who has, someone who doesn't have a lot of the underlying trait is more likely to respond strongly disagree or disagree. So in other words, that item wouldn't apply to them. And specifically, what we're looking at with our item category characteristic curves is the likelihood of selecting a particular response item. So basically, the graduated response model approach models the probability of scoring a given category in a given category or higher, given the respondent's level of ability. So their level, like I said, their level of procedural justice in this case. So for example, somebody who has the high degree of procedural justice is more likely to answer on the high end of the scale, so on the 4 and 5 end of the scale. Yeah. Oh, specifically, when the curve approaches 1, it indicates high response versus below 1, which is a less responded or less chosen response option. So basically, more people for item PJ3, so for item 3, more people that didn't possess the procedural justice underlying trait responded that the item didn't apply to them, whereas less people responded to the middle option, middle of the road option, with neither agree nor disagree. But basically, our item category characteristic curves give us some information about the likelihood of responses. And ideally, when we give a Likert scale, we want to a sample of respondents, we want all of our curves here to be relatively high or relatively close to 1, such that it would indicate that within our sample, everyone has approximately selected one of these given responses. So we wouldn't want one of the responses to be super, super low, because it might indicate that we would need to reduce our range of responses. So if this was a 7-item scale, for example, that might indicate that we would want to reduce our number of responses to a 5-point scale versus a 7-point scale. All right, so that's our first item. Now we're going to look at our second item. And again, we see roughly about the same pattern for each item. Let's go check the others. Okay, good. Now we again see the roughly the same pattern. Now we're just seeing that less people, if you saw our third option kind of flattened out a bit, suggesting that less people have responded to it. So basically the peakness of our curve here indicates the likelihood of response. So we're looking at oops, I'm gonna go back, see if I can explain this a little more clearly. Basically, so from this window here, from here to here, people with less of the trait are more likely to respond with option 1. And then we see right about from here to here, people are more likely to respond with our second option. So strongly agree, strongly disagree, agree, if I can get them right. Strongly disagree, neither nor, agree, strongly agree. Right. So they're more likely. So we're looking at which point our curves cross here. So they're more likely to, if they don't have the construct latent trait as it is measured in the item, they're more likely to respond with strongly disagree. And then as we move up in ability, they're more likely to respond disagree, it doesn't apply. As we get higher into the higher end of the scale, or theta space, where the item does apply, you start seeing, okay, it does apply to me. I do agree, or I do strongly agree. And again, we see the difference here, looking at each point that their curves cross. So from this window to this window, they're more likely to respond with item 4, or option 4, until we get on higher in the scale. So there's basically this intersection of level of ability or level of the trait and the probability of response. So as we move up, we start seeing up until this point, so about -2. So theta space wise, this would be our average, this would be below average, and this would be above average in terms of the construct. So about -2, below average, we start seeing that they start answering more of the disagree option as opposed to the strongly disagree. And as we get up into the average, we start seeing more this small window here of, hey, I don't really think it applies to me. I neither nor agree or disagree. And then as we go, we see 0 being our average point. We see as we go up the scale, we start seeing more of our strongly agree option. So that was a long way around trying to explain item response category characteristic curves, but there you go. So roughly, we're seeing roughly about the same pattern. The other thing too that we want to check for is the order of the items. So order of the responses rather. So in other words, if they have less of the item, are they more likely to respond to 1, 2, 3, 4, 5? Great. So all of our items are actually, or responses to our item are actually in order in which we would expect. That is, if they have less of the underlying trait, they're more likely to respond with these 2. If they're unsure, they're more likely to respond with 3. And if they have a high degree of the trait, then they're more likely to respond with more 4s and 5s. And that's what we'd expect. All right, so now that's our item characteristic, category characteristic curves. Now we're going to move to our item information curves. Now the item information curves essentially sort of transforms the logarithmic curve that we see in an item characteristic curve, where it just goes kind of our S curve goes up and goes over, kind of like this one right here. Essentially, it's taking this logarithmic curve, like option 5 here, logarithmic curve, and it's transforming it into essentially kind of a normal distribution curve, so a normal bell curve. So that is our next plot, I believe. There we go. So these are our item characteristic curves. Item information curve. And essentially what we're looking at is where, with respect to our underlying construct, so for example, ability, where with respect to this underlying construct is our information assessing. So for example, if the items, these items are really actually assessing the full range of the scale, in the sense that we have coverage of all the items from the low end through the middle to the high end. But there are those cases in which the item information curve kind of hovers over the essentially has 3 positions it could hover over. It could hover over the low end, it could hover over the middle, or it could hover over the high end. Basically, that's what that's telling you is the essentially where the information from that item is pulling from. So more people are saying, when they respond to that item, more people are saying, I don't agree, I strongly disagree with that item. But as we get as we go up more in the terms of our level of the trait, respondents are more likely to answer in the middle of the range or above the range. Basically, we're looking at the amount of information that's provided by the item. In peakness, basically, peakness would mean a better item information curve. So item 5 would be probably our best item, even though it's hovering right around our average level of theta, average level of our underlying construct. But we see that it does get into the higher end of the scale as well, which is kind of what we want to see. That way, like I said, we want to have the entirety of the scale kind of spoken for, I guess, in a weird way of saying it, rather than having just one portion of the the level of the underlying construct being assessed. So we see that some people, based on the item, some people are saying, yeah, it applies to me. And some people are saying, no, not really. But these are the people that have less of the construct, more of the construct, and the most of the construct, essentially. But we'd see, so based on the peakness, or a parameter, we're basically saying that when we get down to items 4 and 6, these start being um, less meaningful items to us in terms of the information provided um, by the items that we've used. So ideally, we would want all our items to hover around here in terms of peakness. But yeah, that's pretty much how you walk through item response theory with respect to a polynomous scale. Cheers.